The velocity of an object as a function of time is shown in this figure. The acceleration is constant during the first 4 seconds of motion. Here's 4, and we have this straight line between 0 and 4. Since we have this straight line between 0 and 4, if I took the derivative, it's going to be constant. The acceleration is constant during the first 4 seconds of motion, so the velocity is a linear function of time. V of t equals 0 at t equals 0. They're just saying there's a 0.00. And the velocity is equal to 80 feet per second at t equals 4, which we can see right here because it says 80. And the velocity is constant during the last 6 seconds. And my A is going to be find. First thing we have to find is the equation of the lines. And I'm going to start here with from 0 to 4. Well, I know my y-intercept is 0. So I have y, we can say y of x, or just y, equals mx plus b, where b is 0. M is going to be the slope. I have this point here, which is 4, 80. And I have this point here, which is 0, 0. Y2 minus y1 is 80. X2 minus x1 is 4 times x plus 0. Y equals mx plus b. A lot of times you might be even better off using point slope form, but this is really pretty easy to get in slope intercept. This is just 20x. Now we know y of x equals 20x. Piecewise functions look like this. Because this is 2 different pieces. I can't write one equation for the entire graph, but I can say y of x equals 20x when x is between 0 and 4. And then I can say that y is equal to 80 when x is between 4 and 10. So I've now found the equation of the two functions that actually make up this graph. I'm going to do D first because we can take the area of a triangle and we can take the area of a rectangle and we're good to go. So I'm going to do D first. I know it's out of order, but this should be what we should get is exactly the same answer when we're done. So for D, I have this triangle. And the area of a triangle is 1/2 base times height. So 1/2. The base here is 4. This is the base. And obviously this is the height. So 4 times 80, which is 160. And what are the units here? Feet per second. So this is feet. This is actually going to be feet squared. Okay. So that's the area of my triangle. The area of my rectangle, which is this part right here, obviously. The area of that is going to be base times height. The base is 10 minus 4, which is 6. I'll just write 10 minus 4 times 80, which is 6 times 80, which is 480 feet squared. And if I add those two together, I get the total area of the triangle plus the square, or rectangle, total area is equal to 640 feet squared. The acceleration is constant during the first 4 seconds of motion. Now, the first 4 seconds of motion are here. And remember, this is actually v of t. So if I took the derivative of this part right here, which is the straight line, notice I would just get 20, which is a constant. So the derivative of the velocity is the acceleration. If I have a constant velocity or a zero acceleration, then I'll have, if I have a constant velocity, which here it's 20t, and I take the derivative of that, I get a constant, which is 20, and accelerating at a constant speed of 20 feet per second. When you see a straight line, the derivative of that is constant. We should get, when we take the integral, we should definitely get 640 feet squared because that was an exact value. I didn't estimate it at all. Calculate the exact area under the velocity curve. In other words, find the total distance traveled. Because remember, the derivative of the distance is the velocity. So the integral of the velocity is the distance. So we have to integrate. We're saying delta x is the distance I've traveled. They're just using that. It's not the same delta x as we used before. Because we are now actually, if we would call it anything, we would call it delta t, because it's a change in time, not x. Okay, we want to integrate, which is the same as my distance. And we call position S of t, we call velocity v of t, and acceleration a of t. So this is actually position, is the same as the area under the curve, which is going to be equal to the integral from 0 of 10 of v of t. But as you can see from right here, I have two different functions. So I'm going to break them up into two different pieces. And I'm going to say, I'm going to go from 0 to 4 of 20t dt. And I'm going to add on to that the integral from 4 to 10 of 80 dt. Because I have two different equations that happen in two different places. So I have to really separate them out. Now it's really just a matter of doing the integration. Again, the power rule. We're going to use two rules. First, I'm going to take the constant outside of the integral just to help a little bit here. And this is 80 times the integral of 4 times 10 dt. And then we have 20. The integral of t to the first power is t squared over 2. And I'm going to evaluate that between 0 and 4. Sometimes people just make a straight up and down line. I don't know, when I learned calculus, we had that little bracket. But a straight up and down line is fine. And here, notice we have nothing, but there's a 1 there. And what derivative gives me 1? Well, the derivative of t would be 1. So the integral of 1 would be t. This would be 80t. And I'm going to evaluate this between 4 and 10. And I'm not going to worry about the constants because, again, I have a definite integral, which means I'm going to find the value. If I didn't have these 0 to 4 and 4 to 10, then I would always have to add a plus c at the end. Let's just evaluate this. So we get 4 squared is 16. 16 divided by 2 is 8. 8 times 20 is 160. And then I'm going to subtract by plugging in the bottom number, which is just 0. So I have 160 plus, and now I have 80 times t is 10 minus 4. It would be the same as if I said 80 times 10 minus 80 times 4, right? I think this will be a little easier for me to calculate. So I have 160, which is good because that's what we said the area of my triangle was. And that is the area of my triangle. Plus 80 times 6, which equals 160, plus 480, which is awesome because that's what we said the area of my rectangle is. And the total area, again, is 640 feet squared, which is what I said my area was.